Hello everyone, welcome back to a new video. The agenda for today's video is we will be discussing the NQT type of questions where the registrations for NQT has already been started and the exams are from March 10th. So, we hardly have 15 to 16 days of time to cover the whole syllabus. So, now NQT has started for 2026, 25 and 2024 batches. So the TCS people are majorly focusing on digital and prime profiles. So solving the coding questions is very important to grab the offer of digital and prime. So we will be having two coding questions in our examination. The examination would be of 190 minutes and the coding will be asked in the advanced section. So we will be having two coding questions and the level of coding questions is very easy in TCS NQT. The people majorly gets confused in taking the input and all. We will cover that. I hope there was a session already for taking input, how various types of inputs are been taken. You can definitely take a look on that. Now today we will be discussing the type of questions that are mostly asked in these type of service based questions, and we will be able to understand how we can tackle these questions. So now let's start with the first question with no due. So the first question is first non-repeating character. The first question is first non-repeating character. First non-repeating character. What is this first non-repeating character? Let's read the problem description. So given a string, find the first character does not repeat. If none exist, print -1. So we will be given a string, okay? We will be given a string. So it would be some s equal to, here we will be having some string. So for example, let's take string s equal to a, b, c, d. So this is my string. Now, what is the first non-repeating character? What is non-repeating character? Every character is unique here, but we want the first one. What is the first non-repeating character over here? It is a. So for this, answer would be a. Okay. Now, let's take S2 is equal to, let's take A, B, C, D, C. For this, what my answer would be? A is repeating twice, so A is not my answer. B is also repeating twice, so B is also not my answer. C is also repeating twice, so C is also not my answer. So the first non-repeating character that we have encountered here is D. Okay. Here only one non-repeating character was there, so we are written. So let's take another example also. So it would be A, B. So let's write C, D, C, F. Let's say this is my string. So here non-repeating characters are D and F. They are not repeating, but we want the first one. So D is non-repeating first character, so we will written D. So what about this? What about this? S4 is equal to A, B, C, B, C. What here? So A is getting repeated, B is also repeated, C is also repeated. Here no non-repeating character, so here we will written -1. So I hope the problem statement over this question is very clear. So how can we do this? So let's understand. We can definitely use hash maps here. Hash maps is a data structure of two things, that is two data types. One would be key and its corresponding value. Here our data structure would be something of map of character comma integer. Why? Character is the key because we are dealing with characters and integer will store its frequency. So this would be our data structure. So let's insert this. So if we put the values into the hash map, how it looks? So it was A, B, C, D, C, F. This is my map, okay? Now let's write. So first we are at A. Now A, its frequency is 1. Then we went to B. Now B's frequency is also 1. Then we encountered A. A we will modify with 2 because we have encountered A twice. Then we came to B. So B is also done. Then we came to C. We will introduce C and with a frequency of 1. Then we came to D. D with 1. Then we come to C. C is incremented. Then we come to F. F here. Okay. This is my map. Okay. This is its key. and it is the value. So it is clear, very clear how my map is stored. So now I will iterate over my map. So I will come at A. Is my A's frequency 1? No. So A is not my answer. Now I will come at B. Is my B's frequency 1? No. So I will not take this answer. Now I will come at C. Is my C's frequency 1? No. I will come at D. Now the answer comes. D's frequency is 1. So print D. This is our simple approach. Now let's also understand for another test case. It was A, B, B, C, C. Let's take for this. My map would be something like, this is my map, right? A2, B2, C2. I came here. No. I came here. No. I came here. No. Print -1. This is my simple approach. Now what TCS expert students is writing code from the scratch. They will not give you the header function, anything, main function, nothing. You should write the whole function from the scratch. Unlike the other late code or something, you will just write the function only, right? But here you need to write the whole thing. So now let's simply write the whole function from the scratch. So we will include our header files bit/stdc++.h. The people who are coding in C++ use this header file because this includes every header file, namespace std, and write the main function into main function return 0. First thing is we need to take an string as input, string s. So it would be string, right? String s, scene s. Taking input is done. Now we need to put the values of string into the map. So define a map of character comma integer mp. Right. Now put the values for int I equal to 0, I less than s dot length I plus plus. Right. How do we put mp of s of I? S of I is a character. In the place of character, if we encounter that, just increment its count. Putting of characters in map is done. Here. Now we will just iterate over my map. It would be something for auto it in mp. What does this auto it in mp mean? So let's understand. So this is my mp, right? This is my mp. So I am doing auto it in mp. So this it is of two things. This is it. It is character comma its frequency. So it is key comma value. It is of type character comma integer. So it is having two things. One is it dot first. It dot first is key, and it dot second is value. How do we access? Did you understand? It dot first gives us key and it dot second gives us value. So we can definitely do something like, see what I'll check, if my it dot second, what is this it dot second? It dot second is its corresponding frequency. If my it dot second is equal to 1, then it is non-repeating, right? Then I will just print it dot first. What is it dot first? Its corresponding key, that is the character, and we can return from here. If we did not encounter anything there, we'll just print -1. How simple code it was. So if we take an input, it was, let's take for A, B, C, D. For A, B, C, D, our answer was A, right? Let's check. Submission is queued and perfectly we are getting A, B, C, D. And if I introduce something, let's repeat A, then my answer should be B. Now my answer should be B right here. It is working properly. Now let's take A, B, B, C, C. Nothing is single, so it should be -1. -1. So my whole logic is working very fine. So this was the first question. I hope you have got great understanding about this. Now let's remove the whole piece of code and let's move forward to the next question. No, the second question is very interesting question. So the second question is equilibrium index of an array. We are given an array, find an index such that the sum of elements on its left is equal to the sum of elements on its right. Return -1 if no such index exists. So let's take something very good example. What he is saying that we are given an array, okay? We will be given an array. So he wants some index where the sum on here, if we are here, the left sum should be equal to the right sum. So let's say the left sum is 20 here, then the right sum also should be 20 here. We will not carry this index. So it might be anywhere. So if it is my array, see here, let's take some elements 10, 20 and 5, 3, 2. Okay, this is my array. Now if I am at this index, let's write a index 0, 1, 2, 3, 4. If I am at the first index, what is the left sum? The left sum is this, right? The left sum is 10. And what is the right sum? Right sum is 5 plus 3 plus 2. The right sum is 10. Is my 10 is equal to 10? So 1 is that index where the left sum is equal to the right sum. Got it? Is anywhere else we are getting that? Here we can't, there, here is not. We can take another example. Let's take another example. So okay, let's take 20 over here and 10, 5, 5 and 20. Let's check. So this is that index where the left sum is equal to the right sum. The left sum is also 20 and the right sum is also 20. I hope you have got the understanding. So how to solve this question? So let's take the first test case only. 10, 20, 5, 3, 2, 0, 1, 2, 3, 4. These are my indices. So first what I will do is I will calculate the total sum of the array. What would be my total sum? Total sum would be 10 plus 20 plus 5 plus 3 plus 2. It would be 30, 35, 38 and 40. My total sum is 40. Right. Now I will iterate over my, let's take this. Now I will just iterate over my array. So I will just write for I equal to 0, I less than n, I plus plus. Now we can do right sum. Right sum. What would be my right sum? Right sum would be total sum minus left sum minus the nums of I. Or if let's say it is my nums, the array name is nums, then it would be nums of I. So the right sum would be, total sum is 40. What is left sum? We'll take left sum as 0 because we are currently at 0. Left sum is 0 and my nums of I is this, right? Nums of I. We are at 0th index. So we'll do minus 10. So my right sum would be 30. Is that correct? Yes. The right sum is 30. Then we'll check if my left sum is equal to right sum. If it is, then return the index. And if it is not, left sum plus equal to nums of I. This is a simple code how we'll just do that. If anything does not come, we'll just return minus 1. This is how simple it is. Let's write the code and understand how it is working. So first thing, we want an size of the array, int n, c in n. Then we want an array, so we'll declare a vector of int n. Then we'll take the input for int I equal to 0, I less than n and I plus plus, c in v of I. This is how we take the input. Now it is very simple. First thing is we want the total sum. Let's write int total sum equal to 0 for auto it in v, total sum plus equal to it. This will give my total sum. Okay. Now int left sum would be 0 for int I equal to 0, I less than n, I plus plus. Int right sum would be right sum would be just the total sum minus left sum minus the v of I. Anywhere if my right sum is equal to the left sum, then we'll just print that index and return over from here. Or else it is not the case, then I'll just do left sum plus equal to v of I. If we came out of the loop and we did not return 0, then there is no such thing equilibrium index, so we'll return this. So what was our input? The input was something like 10 20 10 20 10 20 10 20 5 3 2. So 10 20 5 3 2, the equilibrium index was 1, right? We will return 1. Let's see if our code is working correctly or not. Here it is giving -1. Let's see why it is giving -1. For I int equal to 0, int I equal to 0, I less than n, I plus plus, int right sum equal to total sum. Okay, we are taking input, then we are traversing. Let's print the total sum once. Let's understand why actually we are getting wrong things. Not I2, it would be total sum. We are getting 30, but we need to get 10 20 5 3 2. We need to get 40, right? But why it is giving 10 20 5 3 2? Wait, for where, why, 1 second, let's, for int I equal to 0, I less than n, I plus plus, total sum plus is equal to v of I, c out v of I, sorry, c out total sum. We need to get 40 as our total sum, right? We are calculating total sum as wrong. Why are we getting 30? It should be 10 20 5 3 2. Oh, we have not given the size, right? That's why it is getting wrong. So we need to specify the size of the input. So it is 5. The input format was wrong, that's why it is giving wrong. So what was happening previously is, see, this is the small things that we get wrong. So previously I gave something like this. So what it specifies is, the size is 10, but we are only giving this as input. So it is calculating 20 plus 5, 25, 25 plus 3 is 28, 28 plus 2 is 30. That's why. So, but what our compiler is expecting, it is expecting the size also as input. So we will just give 5 as my size and we will define the 5 elements. Now if you see, we are printing total sum as 40 and also our equilibrium index is 1, that is 20, because the here the sum is 10 and here is also the sum is 10. So 1 is that index where the left sum is and the right sum is equal to same. This is how we solve the question. So if I just dry run this, let me just dry run for your better understanding if you have understood this code or not. So let's understand how actually did we solve this. 1 second. So yes, 1 second. I hope it is visible. Yes, it is visible. So firstly we are defining n. So n is 5 and the elements v were 10 20 5 3 2. Okay, now we have calculated the total sum. Total sum was 40 for us. Total sum was 40. This is done, this is done, this is done. Now we have printed also. Okay, now we have initialized left sum with 0 and we are right writing. So now the I is equal to 0. The right sum is 40 minus left sum is 0 and v of I is, v of 0 is 10. So right sum is 30. Is my 30 and 0 same? No. So we are, what we are doing, this not that this did not get execute. So we came here, left sum plus equal to v of I. So we are incrementing our left sum by 10. So this would be 10. Now we'll again redefine. Right sum would be total sum, that is 40 minus left sum is 10 and v of I is 20. Now the right sum is 40 minus 10 is 30, 30 minus 20 is 10. Okay, right sum is 10. Now we will check, is my right sum is 10 and left sum is also 10. So both are equal. So print the index. We are at first index. So print 1, I is 1. So we are printing this. This is how we easily solve this question. So let's move forward to the next question. So yeah, we have successfully solved two questions, and let's move forward to the third question. The problem statement is first and last occurrence of an element. So we have been given a sorted array and a target value. Find the first and last index of the target using binary search techniques. If not found, return -1 and -1. So what is this question stating is, we will be given an array, and one thing is very important is this is a sorted array. In question they may not say that use binary search or something. So they are saying that we want the first and last occurrence of a specific target value in the given array. How can we solve that? Let's see an example. Okay, so 1 2 2 2 4 5 7 7 9. Let's say this is my array, and let's write or even write its indices. Okay, let's take this is as my array 0 1 2 3 4 5 6 7 8. This is my array. This is completely sorted. Let's say my target is 2. If my target is 2, I want its first occurrence. Where is its first occurrence? This is my first occurrence. And what is its last occurrence? This. So I need to return 1 comma 3 as my answer. This is example number 1. Okay, and example number 2 would be 1 2 3 4 5 6. Let's say 1 2 3 4 5 6 7. Let's say this is my array, and target is 2 again. This is the first occurrence, and it is also the last occurrence. So here the answer would be 1 comma 1. So when would be my answer? -1 and -1 is, let's say my target is 10. Is 10 over here? No, 10 is not in the array. So the answer would be -1 comma -1. This is the problem statement. So there are two approaches which we can follow. One is linear search. We can linearly search in this array, get its first index and the last index, which will give us the answer. But we don't do, because it takes O of n time complexity. We can definitely do something better, which is O of n cross. That is, we will not take this O of n, but we'll take O of log n. When log n kind of things come, we always think of binary search. Right, let's implement this logic using binary search. So yeah, we were solving the first and last occurrence. Firstly we are taking the input for the size of the array, then taking the input for the array. Then one thing, we want the target element, like which one do we need to actually find the first and last occurrence. So let's write their function. In first would be get first function. We'll pass our array with the target value. This will get our first, and second will also will be requiring two methods. So we'll apply the binary search. So lastly we will print them. See out we'll just write first. It was first, right? First, then second, and return 0 is common. So let's implement those functions. It would be int get first of vector int v comma int target. So what the first indices would be, let me explain with an example. So let's go to our iPad screen first. See how we will be solving this is. So let's assume one. What happened? One. What is happening? Why it is not? 1 second. Let me fix that. Uh, yep. So it was my input was 1 2 2 2 4 6 7. Let's assume this is my input. Okay, this is my input. Let's write its indices. For this my answer would be something like 1 comma 3, because this is the first occurrence and this is the last occurrence, right? For target 2, for target 2 we are talking about target number 2. So it is at first index it is repeating first, and at the third index it is the first occurrence, it is the last occurrence. So how we can do? For first occurrence and second occurrence we will use the binary search because it is a sorted space. So how we will use the binary search is, initially we will do low equal to 0 and high equal to n minus 1. So low would be 0 and high is 6 minus 1. So sorry, the size is 7. No, 7 minus 1 would be 6, right? It is 7 sized array, so n minus 1 would be 6. So we will calculate the mid would be low plus high by 2, so 6 by 2 would be 3. So we are at here, the mid is at here, right? So we want the first occurrence. What I will check, if first condition would be if my array of mid is equal to target. In normal binary search, if it is equal to target, we have got our element, but here duplicates are there, so we want the first occurrence. So if I already encountered here, there, then it might, I want the first occurrence. So first occurrence would not never lie here, right? On the right side, it would be on the left side. So I will just reduce my search space by doing high equal to mid minus 1, right? Am I right? High equal to mid minus 1. Why? Because my low was here, my high was here. I will not get the first occurrence at the right side, so I will just replace my high by mid minus 1. So if I do that, so high would be here. Now high is at 2. Now I will calculate again. It would be 0 plus 2 by 2 and I am at 1. So mid is here, right? Now I will check again if it is array of mid is equal to target. Yes, again I will go left. If I went left, you see high as equal to low. It is the breaking condition of binary search, right? This is how we simply write the code for getting the first thing. So if I write the code and I will dry run this case, so you will be easily understanding that. So let me just do a small change over here. Now let's write. I first required size, right? It would be int n would be v dot size, right? Int low pointer would be at 0 and high pointer would be n minus 1 index. So my classic binary search would be, while low is less than or equal to high, I will calculate mid. Int mid will be low plus high minus low by 2. This would be my mid, right? I will just check if my v of mid is equal to target. Okay, I got my target, but I want the first occurrence, so I will just do high equal to mid minus 1, because there might be a possibility that even after that index you might get something better in the left side. The second condition would be else if v of mid is less than target. So this condition would be something like, see, if your v of mid something, it is, if it is less than target, then your target is lying on the right side. So what you will do, if your target is on the right side, you will simply do low equal to mid plus 1, and the last case would be high equal to mid minus 1. This is the simple things you do in binary sets, right? Else high equal to mid minus 1, right? This is how simple it is. At last you can simply do You can also calculate into answer equal to -1 and store your answer in answer equal to mid and high equal to mid minus. You got one of the best answer, but you can even look for it, and at last you will return the answer. Similarly, what would be for the get second? Same code. You will just copy paste the same code. See, get second would be this, everything remains same. If v of mid is equal to target, I want the last occurrence, so I will not go left, I will go right. I will just replace this statement by low equal to mid plus 1. That's all. We have written the both codes. Now if I run by giving an input, let's say my input was, let's remove this. My input was something like, where is my input? It was 7 sized array, right? 7 sized array. 1, 2, 2, 2, 4, 6, 7. 4, 6, 7. And my target was 2. Are we taking the input for target? Yep. So for this, the first would be first index and second would be third index. First is first index, second is third index. This is how simply we can solve this question. If I just dry run it for get first, you will easily understand how get second is implemented. Okay, let's see how it is implemented. Let's go to the iPad screen once, and if I explain this, you will be easily understanding how get second is also implemented. Okay, so this is the get first function, right? Our input was 1, 2, 2, 2, 4, 6, 7. Let's also write the indices 0, 1, 2, 3, 4, 5, 6, and target is equal to 2, right? Now we have calculated n. N is 7. Okay, low is equal to 0 and high is equal to 6. This is also done, and we are also marking answer is equal to -1. This step is also done. So is my low less than or equal to high? Yes, low is less than or equal to high. I will calculate the mid. Mid would be 0 plus 6 by 2, nothing but 3. So I will just check, is my v of mid, what is v of 3? V of 3 is 2. Now first condition, is my 2 is equal to 2? Yes, correct. So I will store answer is mid. So update your answer by 3 and high equal to mid minus 1. High would be mid minus 1. What is mid? Mid is 3. 3 minus 1 is 2. Iteration is done. It will not go into else if, it will not go into else. Now I will again check. Is 0 less than 2? Yes, 0 is less than 2. Calculate mid. Mid would be 0 plus 2 by 2. Mid is 1. If your mid is 1, what is v of 1? V of 1 is also 2. Again I will go into this. Is 2 is equal to 2? Yes. So answer equal to mid. So update your answer by 1 and high equal to mid minus 1. High is mid is 1. 1 minus 1 is 0. Now I am at low is equal to 0 and high is also equal to 0. And now mid would be 0 plus 0 by 2, and 0 plus 0 by 2 is again 0. Now we'll compare. If v of, what is v of 0? What is v of 0? V of 0 is 1. Is 1 equal to equal? No, this will not go. If 1 is less than target, yes. So I will do low equal to mid plus 1. Low equal to mid plus 1. Mid is 0. 0 plus 1 would be 1. Now low is greater than high. We will get out of the loop and return the value in the mid. What is mid? Return the value in the answer. What is answer? Answer is 1. So this is how 1 is printed at the first. So similarly you can dry run for get second also. It is very easy. So this is how this function is implemented. Now let's move forward to the next question. So the next question, we have solved this one. Second one is also done. Third one is also done. The fourth question is majority element. Very important question, asked many times. What is a majority element? Given an array of size n, find the element that appears more than n by 2 times. If no such element exists, return -1. Very easy question. So what they are saying is, we will be getting an array as input. And there will be exactly one element which would be repeating more than n by 2 times in an array. We need to print that element. So that is the question. For that, similarly, we want the size of the array as input and also the array as our input. Also, now For example, if I make you understand, if my v is something like 1 2 3 2 3 1 1 4 1, so 0 1 2 3 4 5 6 7 8. So yes, yep. Now we will just this is our input, n is 9, and this size of the array is 9, and this is my input of array. So I need to return that element which is repeating more than n by 2 times. So it would be something like 1 is repeating 4 times, 2 is repeating twice, 3 is repeating twice, and 4 is repeating once. So this is how it is repeating. 4 plus 2 is 6, 6 plus 2 is 8, 8 plus 2 is 9. So this is a frequency. If my any frequency is greater than n by 2, return that element. So for this we can easily use map data structure. So map of integer comma integer, we'll put the elements and store it something like 1 is repeating 4 times, 2 is repeating twice, 3 is repeating twice, and 4 is repeating twice. We will iterate in the map and check whose frequency is greater than n by 2 and return that element. Very simple question. Let's code it out. So here we want a map, right? Map of integer comma integer mp. For auto it in v, I will put my elements mp of it plus plus. For auto it in map, if my it dot second is greater than or equal to n by 2, then cout it dot first, return 0. If you don't get anything, then print -1 over here. This is a simple code. See, the size of the array was 9. The size of the array was 9. 9 by 2 gives you 4. So it is greater than or equal to 4. So you will return 1. 1 would be answer for this. Let's take the input. Input was, the size was 9, and the elements were 1. The elements were 1 2 3 2 3 1 1 4 1. That's all. So if we run, the answer should be 1. This is how simply you can solve this question. So let's move forward to the next question. I am not taking much time and not dry running this. It is very simple question. You might easily understand. Let's move forward to the next question. So let's jump into the next question. The next question is two sum, that is sorted input. So let me explain you the question. The question is very straightforward. We will be given an array. We will be given an array which will be sorted. So we need to find two indices so that their sum ups to the given target. If there is no element or any index which is getting summed up to the target, then we will return -1. This is a very easy question. So let me just give you a test case. Like let's say it is a sorted space, right? It's 1 4 5 7 and 9. Let me say this is as our array 1, right? So the problem statement here is saying that, and my target is equal to 12. We need to find two integers in an array whose sum is equal to the given target. Here we can use the brute force approach of O of n square, where we will be using nested loops for I equal to 0 to n. Again j, we will compare 1 with every element, again 4 with every element, 5 with every element, 7 with every. This is a brute force approach. But the thing over here is the input is sorted. When the input is sorted, we can use two-pointer approach. Two-pointer approach. How can we use two-pointer approach? The input was something 1 4 5 7 and 9, right? It was 1 4 5 7 and 9, and our target was 12. The thing is very simple. Put a I pointer over here and j pointer over here. We'll calculate the sum first, that is I plus j, that is corresponding element. It is 10. I will compare, is my 10 equal to target? Case number 1, if my 10 is equal to target, the sum is equal to target, then return I and j, right? If my 10, that is sum, less than target, if my sum is less than target, then I will increase I, because my sum is less, I want greater sum, so move I front, right? So here we'll do I plus plus. The case would be, if my 10 is greater than target, if my sum would be something 14, then if I do I plus plus, 4 plus something would be greater than 14. So in this case we'll do j minus minus. In the whole iteration, if we did not get anything, then we'll return a minus 1. So this is how simply we'll solve this question. I will write the code for this and we'll try run. You will understand it very clearly. So this was the previous code. We all don't want this, we just want a array as input. So here we can take two pointers, int I equal to 0 and j equal to let's say int I equal to 0 and j equal to, it was n minus 1, right? I'll do while I is less than j. When I is less than j, I will do few things. Int not mid, why I'm writing binary search. It would be, if my v of I plus v of j is equal to what we say, if my v of I plus v of j is equal to my target. So firstly we also need one target, int a target, and c in target. If my sum is equal to target, then see out I j, will print them and return a 0. Else if my v of I plus v of j is less than target, then I will do a I plus plus, else I will do a j minus minus. If we don't get anything, we will return a minus 1 over here. This is a simple code that we will be doing over here. So let me just connect to my internet. So let's run. And sorry, the input format is wrong actually. The input is wrong. Just close this. So firstly we want the size, right? The input for us was, it was something 5 sized array, and 1 4 5 7 9, and our target was 12. So for this the answer was index number 1, index number 2 and index number 3. So we are easily getting index number 2 and index number 3. This is how simply we will be solving this. If I dry run this, you would be easily understanding. It is not a very critical or very hard problem. It is one of the very easiest problem. So let's understand what was happening over here. So let me just see a quick break between our session. So I want to showcase our premium course that we offer for TCS NQT specific. Here we will be following a structured pattern where daily your classes would be happening, where if I just show you the timetable that we follow, see, every day you would be having, we would be solving the various number of PYQ questions and also taking mock interviews. And if you just go into the content section, you would be seeing something like DSA white book. What is this white book is? It is having around 200 problems which are solutions in C, C++, Java and Python. So C and C++, Java and Python, 3 language support is there. You will be solving various number of PYQ questions, and you can see the TCS coding questions that were asked in 2025 on campus. Also, if you can navigate, and you will see asked 2024 asked question, practices, mock test, English communication, AI tool workshop, old batches recording. You will be having live classes, everything. So in this premium courses, we would be leaving no concern and teaching you the best content. So it is for 1500 rupees. You can definitely invest this and never regret. So let's move forward to the next question. So we were actually dry running this test case, right? So we are defining n, and then we are defining the array of n size, then taking the input. After that we were initializing I equal to 0 and j equal to n minus 1. So our input was something like, if I see our input, it was 14579. So it was 14579. So I was 0 and n is 5 here, and so j would be 4. So we were doing while I was less than j, and we were taking target also as input, right? Target was 12. So target was 12. So we will just compare first v of I plus v of j. Sum is 10. So is my sum equal to target? No. So we will not go into this. We will go into else if part. Sum, that is sum. 10 is 10 less than 12? Yes, 10 is less than 12. So we are doing I plus plus. I plus plus means I equal to 1. Now we will check. If I equal to 1, 4 plus 9. So 4 plus 9 is 13. So my sum is 13. If my sum is 13, and it is greater than my target, so it will not go into this, it will go here. So j minus minus, j minus minus would be j equal to 3. So I equal to 1 and j equal to 3. So 4 plus 7, 4 plus 7 is 11. So sum is 11 now. Sum equal to 11 now. Is my sum equal to target? No, it is not. Is my sum is less than target? Yes, sum is less than target. So I will do I plus plus. So now I is 2 and j is 3. For I equal to 2, my value is 5 and my j value is 7. 5 plus 7 is giving us 12. Is 12 equal to target? Yes, 12 is equal to target. We are printing I comma j, that is 2 comma 3 are printed. This is how simply we can write this logic. Now moving forward to the last question of today's. So it is transpose of a matrix. Given n cross m matrix, computes its transpose. Rows becomes columns and columns become rows. I think everyone know what is the transpose of a matrix. If we see matrix is generally representation of rows and columns. So it is a rectangular arrangement. If we see 1 2 3 4 5 6 7 8 9, this is a 3 by 3 matrix. So there are 3 rows and 3 columns. Similarly 1 2 3, this is 3 rows and 1 column, 3 by 1 matrix. This is a 1 2 3, this is 1 by 3 matrix, that is 1 row 3 columns. This is a rectangular arrangement of elements is known as a matrix. So what is a transpose of a matrix? Transpose of a matrix is represented by a dash or something, a power t. So the rows are interchanged to columns and columns are interchanged to rows. So the question is very simple here. We need to just print, right? If we see 1 2 3 4 5 6 and 7 8 9, if you see this is as our input, what would be its transpose is, it is simply 1 2 3. The rows will be changed to columns. This would be 4 5 6 7 8 9. This would be my transpose. For this it is very simple. When you iterate over ij, it would be printed original matrix. You just print its reverse, that is j comma I. It will print the transpose of a matrix. Just quickly let's write the code for this. So by this we will also understand how to take the input for second, that is 2D matrix. For this we want r comma c, int r comma c, that is row, number of rows and column, r comma c. So we will define a 2-dimensional vector, that is vector of vector int v of n, that is r, comma vector of int c comma 0. Initially we will define everything by 0. This is the initial value, that is 0. This is how we write a 2D matrix, that is 2D array in a C++. So taking input is very easy. That is for I int equal to 0, I less than rows, I plus plus. For int j equal to 0, j less than columns, j plus plus, and I will take that is v of I comma j. This is how we take input. Now let me print my matrix. For first I will just print and show how it is getting printed. I plus plus. For int j equal to 0, j less than columns, j plus plus, and we'll print, right? We'll just print the v of I comma j, followed by a space, and after every row we'll print a new line. So let's first see how our array would be. Let's see. Let's take 3 by 3 matrix. For 3 by 3 we defined as 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the input format, right? The same should be printed in the output. Let's see how it is printing. We are getting some compilation error, so it would be 2 angular brackets, not 1. Let's run it again. So we are getting the exactly same. Now let's print the transpose also. See out the transpose of the matrix is for int j equal to 0, j less than columns j plus plus, for int I equal to 0, I less than rows I plus plus, see out v of I comma j. See out end line. This will give me the transpose of the matrix. Let's see how it is getting printed. So the transpose of the matrix is 147. This matrix is that is first column changed to first row, second column changed to second row, third column changed to third row. This is how simply we can print the transpose of the matrix. So I hope these 6 questions were very helpful for you. We have understood how to take inputs, learned what are two-dimensional arrays, single dimensional arrays, two-pointer approach, what else, two-pointer approach, binary search, and also lower bound, upper bound functions. Everything we have also read, right? And one thing to say is the one problem which we have solved, the first occurrence and last occurrence, there is this shortcut for that in C++. So there is an inbuilt function called lower bound. Okay, lower bound HTL. You can definitely see what does this do. See, let me demonstrate. Vector of int v equal to let me take 1, 2, 2, 2, 3, 4, 5. Let me say this is as my array. Okay, and my target is 2. We for this we have written two functions, right? Get first and get second. It would be done in single HTL function. There is an inbuilt function. How do we see? How do we do it? Let's see. So we'll just write int first occurrence would be simply lower underscore bound. It is a HTL function of C++. It will return a pointer. How to get rid of this pointer? I will say lower bound of will give the iterator, that is iterators, that is v dot begin comma v dot end, and the target value. What is the target value? Let's say it's target only. And to get rid of this iterators, you will just subtract it by the initial pointer. For the index is 1, right? We already took the same example. The 1 will be here, and for second, to get the last thing, you will write lower bound, not, it is upper bound of same thing, v dot begin comma v dot end. The same thing would be repeated over here, and we are missing a trace over here. So if you just print here, see out first, second, it will give the same answers, that is the index number 1 and index number 3. There is some compilation error. It would be v dot begin, not terms dot begin, sorry, v dot begin. Let's run. We are getting the same thing, first index and the fourth index. Why we are getting fourth index? 0, 1, 2, 3. It will, what is upper bound is, it is just greater than the value. For this we will always do a -1, because let me explain what is upper bound. The value which is just greater than the smallest greater than value of the target value, we will say it as upper bound. If you see, if I define another 2 over here, let me put a comma. Now if I don't do second, -1, and print it, it will give 5, because it will give the just greater than value than the 2. than the target value. Here it is giving 5. So this is the simple logic of upper bound and lower bound functions. The same functions with the STL which we are using is, it is implementing the same, the function get first and get second. What the function does is the same function upper bound and lower bound does. So this is about first and second occurrences. The people who knew the STL would solve it in 2 lines rather than writing two big functions. So this is about today's class. And if you want more content on TCS videos, and if you like the way of teaching or the quality of questions or something, any feedback, anything, you can post it in your comments. And I hope I will take the constructive feedback, and I will meet you in the next session. Until then, bye bye.